Have you ever been walking down the street, glanced up, and noticed a bird calmly perched on a power line, sometimes dozens of them lined up like musical notes on a wire, and wondered how nothing bad happens to them? Those same lines carry thousands of volts of electricity, enough to power entire neighborhoods and cause serious injury or even death to a human being. Yet the bird sits there peacefully, preening its feathers, chirping as if danger doesn't exist. It feels almost magical, like the bird knows some secret rule of physics that the rest of us don't. If you enjoy uncovering the hidden science behind everyday things, consider subscribing to the channel. The truth is, this isn't about luck, special insulation, or animal superpowers. It's about how electricity actually works, and why the path it takes matters more than how powerful it is. To understand why birds can sit safely on power lines, we need to look at one simple rule that governs electricity everywhere. Most of us grow up believing that electricity is dangerous simply because it's powerful. We're taught that if you touch something carrying electricity, you'll be shocked. No questions asked. But that idea, while understandable, isn't entirely true. Electricity doesn't behave like a sudden attack waiting for contact. It follows rules, very specific ones, and one of the most important is that electricity only moves when it has somewhere to go. It needs a complete path, or what scientists call a circuit, to flow from one place to another. Without that path, even the most powerful electricity remains contained. This single misunderstanding is at the heart of why birds on power lines seem to defy danger, and why they're not actually defying anything at all. To understand what's really happening, we need to look at how electricity behaves in the real world. Electricity doesn't move randomly, and it doesn't spread out looking for something to shock. It flows only when there is a difference between 2 points, moving from a higher electrical potential to a lower one. Power lines are built specifically to guide electricity along a controlled path. That path begins at a power station and continues through cables, transformers, and substations, all the way into homes and buildings. The metal wire offers electricity an easy, efficient route to follow, so the current stays focused right where it's intended to go. When a bird lands on a single power line, it doesn't give electricity any reason to leave that wire. The bird becomes part of the same electrical potential as the cable itself. Since electricity always prefers the easiest path available, it continues flowing through the metal line instead of detouring through the bird's body. One of the main reasons birds can sit safely on power lines is surprisingly simple. They usually touch only one wire at a time. When a bird perches on a single line, both of its feet are resting on the same electrical surface. That means there is no difference in voltage between one foot and the other. And without a difference in voltage, electricity doesn't move through the bird's body. Electric current only flows when it can travel between 2 points with different electrical potential. In this case, the bird is at the same voltage as the wire itself. There is no incentive for the electricity to leave the metal cable, pass through the bird, and then return to the wire. The metal line is a far better conductor than feathers, skin, or muscle, so the current stays exactly where it's supposed to be. As long as the bird doesn't touch another wire or a grounded object at the same time, it remains electrically isolated. In a sense, the bird is floating electrically, even though it's physically sitting on something that seems extremely dangerous. This same explanation also reveals why humans can't safely do what birds do. A person who touches a power line is almost always connected to the ground, whether through their feet, a ladder, or even the surrounding environment. That connection completes a circuit. Once that circuit is formed, electricity suddenly has a clear path to follow. It can travel from the power line through the human body and down into the ground. And when electricity flows through the body, the result can be severe injury or death. the human body conducts electricity relatively well because it contains water and dissolved salts. Compared to air, it offers far less resistance. This makes people especially vulnerable when they become part of an electrical pathway. Birds avoid this danger simply by not being grounded and by not creating a path for current to flow. They don't need insulation or protection. They stay safe by never giving electricity a reason to move through them in the first place. There's another subtle factor that works in the bird's favor: size. Birds are small, and the distance between their feet is very short. Even though power lines can have slight changes in voltage along their length, those differences usually occur over long distances. For a bird, the voltage difference between one foot and the other is extremely small, far too small to push a dangerous amount of current through its body. The electricity simply continues along the wire, barely noticing the bird's presence. Humans, on the other hand, are much larger. If a person were somehow suspended between 2 points with different electrical potential, the voltage difference across their body could be significant. That larger difference increases the chance that a harmful current could flow. Once again, the bird's safety isn't about immunity or resistance. It's about scale, distance, and the absence of a meaningful voltage difference. While birds often appear completely immune to electricity, they are not invincible. Under the wrong conditions, birds can and do get electrocuted. The danger appears when a bird accidentally creates a path for electricity to flow through its body. This can happen if a bird touches two power lines at the same time, especially if those lines carry different voltages. In that moment, the bird becomes the bridge between two electrical potentials, allowing current to pass through it. The same risk exists if a bird touches a power line while also making contact with a grounded object, such as a utility pole, transformer, or even a nearby metal structure. Larger birds face a greater risk. Species like eagles, hawks, and owls have wide wingspans that can accidentally span the distance between wires or between a wire and nearby equipment. Because of this, utility companies sometimes modify power poles or install protective covers in areas where large birds are common, reducing the risk of accidental electrocution. Birds don't stay safe because they understand electricity or follow conscious safety rules. Instead, their behavior is shaped by evolution. Over millions of years, birds that accidentally perched in dangerous ways didn't survive long enough to pass on those behaviors. Those that instinctively avoided touching multiple wires or grounded objects were more likely to live, reproduce, and pass on their traits. What looks like careful decision-making is often the result of natural selection quietly removing risky behaviors from the population over time. The birds we see today are the survivors of countless small mistakes made in the past. Their seemingly effortless safety is not learned physics, but inherited instinct, fine-tuned by trial, error, and survival across generations. This everyday sight offers an important lesson about electricity that applies far beyond birds on power lines. Voltage alone isn't what makes electricity dangerous. What causes harm is current, electricity actively flowing through a body. A power line may carry thousands of volts, but without a completed circuit, that energy stays confined to its intended path. The moment a circuit is created, electricity moves, and that movement is what makes it deadly. This is the same principle that guides electrical safety in the real world. Electricians use insulated tools, wear protective equipment, and follow strict procedures to avoid becoming part of a circuit. Even a small mistake can turn stored energy into a flowing current. Birds on power lines provide a quiet, real-world demonstration of this rule. They aren't resisting electricity, they're simply never giving it a reason to move. So the next time you look up and see a bird perched casually on a power line, you're not witnessing a miracle or a defiance of danger. You're watching physics quietly doing its job. The bird isn't protected by insulation or special abilities. It stays safe by never completing a circuit and never giving electricity a path through its body. As long as it remains on a single wire and avoids touching the ground or another line, the electricity flows on by, completely indifferent to its presence. Moments like this remind us that science and nature often intersect in the most ordinary places. Once we understand the rules behind them, the world feels a little less mysterious and a lot more fascinating.